Now, in this video, we will be looking at the control statement, and the first control statement is the arithmetic if statement. So, there are basically three types of if statement: arithmetic if, logical if, and block if. And out of that, we will see the first one, the arithmetic if statement. So, the statement is used for the conditional transfer of the control, and this control is transferred based on the value of an arithmetic expression. So you have gone through the arithmetic expression. We have the four types of expression there: arithmetic, relational, logical, and character. And out of that, the arithmetic expression is there. So this arithmetic if statement syntax is if in bracket AE N1 N2 N3. So AE is the arithmetic expression, while N1 N2 N3 they are the statement numbers. So the steps for the execution is something like this. First of all, AE, that arithmetic expression, is going to be evaluated. So whatever you write in terms of arithmetic expression, in that case, it would be considered as the uh, part as the evaluation, and based on it, control will be transferred to. They are the only three N1, N2, N3. They are the only three statement numbers. N1, it will go to the N1 if AE, that arithmetic expression, is found to be less than 0 or negative. In case if AE, arithmetic expression, is found to be 0, it will transfer to N2, and whatever statements are written on the line N1, N2 or N3, that would be executed. Similarly, if AE, arithmetic expression, is found to be greater than 0 or it is a non-zero term, in that case, it will be transferred to the N3 statement number, and whatever statement are there, so that is going to be executed. And this is how the flow chart is will be there. This is the diamond box, basically, that is used for the conditional conditions. Any kind of condition is there, so that is called as a condition box here. And these are the arrows to go either upward, left, or to the right or left direction or in the downward direction. So here A is going to be evaluated, and that's the reason it has been put into the condition box. If it is found to be less than 0, it will go to the N1. If it is found to be 0, then it will transfer to N2, and if it is greater than 0, it will transfer to the N3. So we'll just look at this. Suppose we want to have the roots of a quadratic equation. In that case, we can just go ahead with this flow chart. Now we'll be looking at what are the different terminologies of the flow chart as well through this. So this oval shape is used for start as well as the stop option. This is the arrow. Then you have this rectangular box with this left upward part is the have some cut, look like something SIM card. So this is used for to read any variable or for the input statement. Then you have this arrow to go to the further process. Then you have this rectangular box. This is the perfect rectangle. This is for any kind of evaluation or expression or equation. You can use this rectangular box. Then this is the condition box, the diamond one, the arrow, and this one is the parallelogram for the output statement. So with the help of this output statement, you can display certain things, and these are the things have been utilized here. Oval shape for the stop and start, input. Then you have this rectangular box for the evaluation process. This is the condition, like a parallelogram for the output, condition box, and that's all. So we'll be now looking at the process of how to go ahead for the calculation of roots for the quadratic equation. So first of all, we'll start. Then we'll go ahead with the first of all input of A, B, and C, and then we'll have this. Basically, we do have the formula to calculate roots of quadratic equation, that is minus b upon 2a plus minus square root of b square minus 4ac. Okay, so we have just converted the square root term b square minus 4ac as d, and 2a equals to d. Now if suppose in the square root term this b square minus 4ac is found to be negative, then we'll consider it as the imaginary root. If it is 0, then we'll have the unique root of minus b by 2a, that is d. This is the unique root, it will have the displaying and should stop. Here also it should stop once it is display the message roots are imaginary. In case this is greater than 0, then you'll have the multiple roots, and we'll consider this as this is the square root of d dr, and we'll say x1 as minus b plus dr by d, and x2 is minus b minus dr by d. So we'll have the multiple roots x1 and x2, and it should stop here. So let us go to the program of it. So I've written here program, and then RT AIF, this is the program name. Uh, Display the message program to calculate roots of quadratic equation, and then since you have to input the value of a, b, and c, I have just first of all given the message of enter values of coefficient a, b, and c. So once I enter the values, this message will be displayed, and then you have to read the values a, b, c, and then there's the equation. As you know, there's d equals to b square minus 4ac. I've written here b minus 4 into a into c, and then d equals to 2 into a, so that is twice a. And then I have written here according to the syntax, if d is nothing but this equation, this will evaluate. If this is found to be negative, then it will go to the 100. If d is 0, then it will go to 200, and this d is greater than 0, it will go to 300. So what is on 100? 100 on this statement number, there is a message that roots are imaginary, and then it should stop. it should not go to the second statement. If this D is greater than 0, it will go to 300, and if it is equals to 0, it will go to 200. So if this is found to be equals to 0, it will go to this statement number, and this is x equals to minus b by d. You will get the unique root, and you can display it just like write star comma star unique root, and this is in single quote, and you will have this x. The value of x will be here, and it should stop. Similarly, if d is greater than 0, then it will go to 300 statement number, and on that this dr is equal to square root of d, and then x1 equals to minus b plus you have this dr and this divided by d. Then similarly x2 equals to minus b minus dr divided by de, and you will have this the message will to be displayed multiple roots and the value of x1 comma x2. It should stop, and this will end the program with this end statement. So suppose if you just look at the program here, one of the very simple program for arithmetic if statement, written a program, then program name AIF. I want to know which of the value is greater or equal or smaller. So the message should be displayed as enter x and y. So there should be read statement, and you have to read two values x comma y. Then go to the if statement, if x minus y. So if this is found to be negative, it will go to the 100. If it is 0, it will go to 200, and if it is greater than 0, it will go to 300. So suppose if it is negative, yes, x is smaller than y. If it is, and it should stop. If it is 0, then x is equal to y should be the displaying message here. And if this is greater than 0, then the message should be displayed x is greater than y, and it should stop, and end of the program. So this is how the arithmetic if statement is to be used. In the next video we will see the other type of if statement.